Hello and welcome back everyone to the next episode on SAP Analytics Cloud Training with me Anubhav. In our last episode, we talked about building our first machine learning scenario in SAC using the concept of classification. Classification is a method to identify the truthy or the falsy inside a population of world. We always use classification when the result of our machine learning algorithm is binomial, which is 0 or 1. For example, detecting out of population whether certain patients are affected by corona or not, or identifying with the list of customers whether a customer will churn or not, or identify a particular person which will respond to your marketing campaign positively or not. So we have utilized the concept of confusion matrix, AUC and ROC curve to detect the efficiency or the accuracy of our machine learning model. In today's episode, we will start with our next scenario, which is called regression. So as I have explained you, the regression scenario is typically used to identify when your output variable of machine learning is of type continuous nature. Continuous nature means it's a number. So when the outcome is a number, then we use regression. There are two types of regression, the single regression or linear regression and then multi-regression. Then we talked about the concept of dependent versus independent variable or so-called input and output, which we call it as in machine learning. So in today's session, I'm going to take an example of a regression algorithm, and then I will show you how do you determine the accuracy of such a algorithm. So last time we saw for classification, the accuracy was determined of the model based on something called confusion matrix. But now we will see how the accuracy of regression will get determined. It will get determined based on something called residual. So as I also explained you, a regression is a very simple equation which we also saw in school days during mathematics called y equal to c plus mx. Yes. So if you see here, the alpha 0 or alpha 1 are basically coefficients, and x1 is an independent variable and y is the dependent variable. So y is our output variable and x is our input variable, and the goal of this regression scenario is to identify the value of coefficients. So the goal of machine learning algorithm is to identify the value of coefficient which will determine value, which is our predicted value of y. So that is what machine learning algorithm typically does when we apply regression. So interviewer will ask you what is the goal of machine learning scenario in case of a regression. So it is to identify the value of coefficients. So when we put the value of coefficients in the equation, we get our predicted value. Now I also showed you an example that if I want to predict price of a house, which is actually a function of type continuous nature, we have these alphas, different alphas with which we are multiplying to calculate price of a house. So here, how much weightage each parameter takes for us to calculate price of a house is what the these alpha variables are, right? So now let's move on and see an example where we will see how can the accuracy can be determined for this machine learning algorithm when it comes to regression. So today I have got a simple machine learning algorithm example for regression. So imagine here we have the value of x. So this is the x-axis you can see, and this is the y-axis. So if you see dots, these black dots are nothing but they are the actual value of y. Yeah. Remember machine learning algorithm, we compare the actual versus predicted. If you've forgotten, I would like to quickly charge your mind once again with the concept. This is the concept which we saw. We have the actual value and we have the predicted value. So what does the machine learning aims to do? Machine learning aims to calculate the actual versus predicted. That is what it does, right? So now we have got an algorithm. Imagine the algorithm. Over here we have got a machine learning algorithm. So if I come here, you can see this is our algorithm where you have these black dots indicating the actual value. All right, so that is what it is indicating. And this line what you see, yes, this line is indicating your model, your predicted model. Yes, so this is what the predicted model is indicating. So if you remember the regression equation, it is y equal to c plus mx. So that is the actual value. But then we have this model which is saying cap y cap equal to c plus mx. So you see here mx, m and c, both values are determined already by machine. So this is a already calculated algorithm, and based on that we have got this line. If in this equation you substitute value of x is to 0, you can see the value become point. So x, if I put x0, the value become -2 for y. So you see this slope, this line is somewhere intersecting your y-axis in -2 when x is 0. Yeah, that is what this line indicates. So this line is our model. So if I put here, this line is our used to predict predicted value, output variable value of y. So you can see y cap is your predicted output and y is your actual output. So your actual value of y is this, and y cap is your predicted value. This line is your machine learning algorithm. So let me ask one question. If x is 3, what is the actual value according to this chart, and what is the predicted value according to the machine learning algorithm? Can anyone tell me? Example, as an example, if x equal to 3, what is the actual value? First question. If you remember how to read charts in school days, if you remember how to read charts in school days, if x is 3, what's the value of y? Value of y,
748
guys, I'm asking.
or 748.
No, no. What is the value of y? Think about, think about it. Let me draw, let me draw x-axis and y-axis for you. Once again, school days, guys, school days. I'm not asking
Five.
anything rocket science. Just asking basic questions of school days. If the value of x is 3, what is the value of y? Y, guys, not y cap. I'm asking y. Come on, guys.
So it's
This
5.5.
this black dot is indicating value of y, guys. Where is the black dot? Is the black dot on 5.5? Is the value black dot is on
It's on 6.
5.5?
It's on 6.
It's on 6.
6.
Exactly. So
6.
value of y,
Yeah.
which is actual value of your output, your actual output is black dot. That is your y. So value of y is 6. What is the predicted value of y according to the line? So the line is representing the predicted value.
Okay, so then it's y 5.5.
Yes. So the predicted value is y cap, which is 5.5 according to the chart. So you can clearly see in this diagram the value of y, which is this dot is representing, that is equals to 6. So y equal to 6. But this is my machine learning algorithm. So according to x equal to 3, the value of y cap is intersecting this line over here, which is 5.5. So value of y cap is 5.5, which means this is the actual value. Remember machine learning, we compare actual with, yes, predicted. What's the difference between actual and predicted? Anyone? The real value versus machine is telling you what value. What's the difference between actual and predicted? 0.5. So don't you think we are away? We are not exact. Machine is not predicting correct value exactly. It is far this much from the actual value. Yes, machine learning is far from actual value by 0.5. Is this okay? Everybody understand till here? Is this okay? That machine is 0.5 far away from the actual value. What machine is predicting is 0.5 away from the actual value. Yes, that is called
Okay.
residual. Everybody will be writing in the chat window. What is it called? Please type it in the chat window. This word residual. I want you to write it because it will get registered in your mind. When you go to interview, that time you will know what does it mean. So residual. Only two people have written. I'm waiting for others in the chat window. Please type residual. Residual. What is residual? It's the difference between what is the actual value in a regression scenario versus what machine has predicted. Is that clear? Is that clear, everyone? What is residual? Are you clear? Okay. So now this is how you identify the accuracy of machine learning model in a regression scenario. So let us go ahead and calculate residual for all the different value of x. You see we have multiple dots, 1, 2, 3, 4. So we'll take these four different data points, and then for each data point I'm going to calculate the value of residual. Any question till here?
Yeah.
Okay, no question. So let's proceed further and calculate the value of residual. So now I'm going to go back and we will calculate value of residual for all the value of x. So R is actually called residual. It is how far we are from actual value based on our model. How far our model is away from actual value is called residual. So the formula of residual of ith point, I means the 1, 2, 3 for the number, is y of I minus y of I cap. Y of I cap is the predicted model. You see the value of alpha 0 and alpha 1 are substituted. Yes, that is your predicted model. This model has come, somebody ran something and they've got this model, they've got this predicted model. Yeah. Now we are going to calculate this residual. So let's start with R1 where the value of x is 1. So the formula is going to be y1 minus y1 of cap equals to y1 minus the y cap is this formula 2.5x minus 2. So put here 2.5 x1 minus 2. Yes. And then can anyone tell me what is the value of y1 for x1? If x is 1, what is the value of y1? Who will tell me value of y1? The dot. Tell me the position of the dot for x equal to 1. Tell me the position of dot for x equal to 1. Anyone? Yes. The y1 is 1.
Uh,
You will
6.
tell.
No.
You will tell everything, guys. 2.5 x1. We are doing it for number 1 x1. So 2.5 x1 is this minus 2. Yes. So what is the output? 2.5 into 1 is 2.5 minus 2 is zero point 0.5. 1 minus zero point 0.5 is equal to 0.5. Are you clear? Hello? Are you clear? Hello? Are you clear? The value of residual 1. Value of residual 1. Are you clear? Are you clear with the value of residual 1? Yes, perfect. So you can also see from the chart, guys. Look at from the chart. Where is for x1 the value of y1 cap is this, where I'm intersecting this line, and you see the difference is actually 0.5. From the chart also you can make out, and from formula also you can make out, both are matching. Both are matching. So this is a evidence, this is a testimony that actually both the values are matching as per the calculation also and as per the chart also. Yes. Okay, let's go to the point number 2, which is x equal to 2. At x2 we have 2 points. Yes, so we'll be calculating residual for both. So this was my 1.1, this is, let's say, point 2, this is my point 3, and this is my data point 4. So we have 4 data point, we'll calculate 4 residual. So let's calculate for second residual. It's y2 minus y2 cap equals to y2 minus 2.5 x2 minus 2. Yes, what is the value of y2 for x2? What is the value of y2 for x2? Okay, what is the value of y2 for x2, guys? What is the value of y2 for x2? X2, what is the value of y2? No one? Just simply
3.
read the dot position. Where is the black dot? Where is the black
3.
dot? It's 3. Very good answer.
3.
Yes, very good answer. 3 minus 2.5 into x is 2. So we're calculating for number 2. Yes, minus 2. So 2.5 into 2, 5. 5 minus 2 is 3. 3 minus 3 is 0. Wow. Do you see? Do you see for data point number 2, it is exactly on the line. Do you see the data point 2, the black dot is exactly meeting the line, which indicates that the predicted value and the actual value was same. Hence the residual was 0. And you can see the formula. They are intersect, they are, it's on the same line. So the residue, there is no residual. It's not far from the line. It's on the line itself. That's why residual is 0. Let's calculate for data point 3. Y3 minus Y3 cap. So Y3 minus 2.5 X3 minus 2. So here it comes as, for again number, the third data point, for X equal to 2, the value of Y3.
2.
Y3 is 2. So 2 minus 2.5 into 2 minus 2, that comes is minus 0.5. You see it is below line, so this one was above the line and this is now below the line, so it is minus 0.5. That's the value of residual 3. This is your residual 3, you can also see from the chart. Yes, now comes is this residual 4. You can calculate yourself when you are practicing this training from my video again. So y4 minus 2.5 x4 minus 2. So 2 minus 2.5 into x, value of x is 3, minus 2, it will be 0.5. So I have calculated all the 4 residual. So these are the residual which will just tell you how far we are from the our actual output from the predicted output. That's how we calculate accuracy. But if you imagine you have 100 data points, so putting every residual, yes, or calculating, putting every residual value to the user is hard to understand. So what we do, we calculate a mean. Mean means average. We calculate an average of all the residuals. So this is called mean absolute error. Mean absolute error. So let's calculate an average. So the formula for this is 1 divided by n. N here is the number. We are going to do a total of I equal to 1 to n. and then we'll say y of I minus yi of cap, basically the residual. Total all the residual divided by number of residuals. So let's total all the residuals. And you see there is a modulus. Modulus means consider the negative value as positive. This modulus means consider negative value as positive. So first residual is 0.5 plus 0 plus 1 plus 0.5. Sorry guys, here I did a mistake. 2.5 minus into 2 is 5, minus 2 is 3. This value is minus 1. I've done a mistake. This value is minus 1. You see, it's 1. It's at 3, it's at 2. So this value is minus 1. I did a mistake. Nobody also asked me, Anubhav, you did a mistake. Yeah. Okay. So 0.5 plus 0 plus 1 plus 0.5 divide by total. There are 4 data points. So we have a total of 2 by 4, and that comes as 0.5. This is your mean absolute error, means all the residuals on average, all the residuals are throwing a average error of 0.5. Okay. Can anybody tell me what is the perfect value, perfect value of mean absolute error if your algorithm, if your algorithm is best algorithm, what is the ideal value of MAE according to you? I'll not complain your manager. Think about it. Zero. Very good, Nachango. Because it's an error. Think about it, guys. It's an error. Do you like error in your work or not? Do you like errors in your work or not? You don't like, right? What is the ideal value of error? Yes, ideal value of error should be zero. So if that's an ideal scenario, but there is nothing kind of 100% perfect. So ideal value of absolute error is zero. Yes. So this is right now you can see 0.5, which means our model is having a accuracy of 100 minus 0.5, 99.5% accurate. Our model is. Yes. So this is the absolute mean absolute error. This is the first characteristics which we use. So we first calculated individual residuals, how far my actual values are from the predicted value, and then we calculated a simple average, simple mean value of these average, and then we have got our mean absolute error. Y4 is 6, right? You are right. I have again done a mistake here in the formula. So the value of y4 is 6. This is 6. So 6 minus zero point 0.5 into 3. Yes, now it comes as 0.5. Yes, it is a mistake while writing. Okay, so now this is the first parameter which is called root or sorry called mean absolute error. Mean absolute error. Yes. So then from this, the second thing which we also calculate, we have other parameters called RMSD or RMSE. This is called root mean square residual. What we want to do is we wanted to basically test if we double the error, if we double the error, is my model getting affected too much? Yes. If I double the error, will my model get affected? And why I do this? I wanted to know how robustness, to check robustness of the error. So let's say what you do is you buy a iron plate from market. Now you get that plate and you wanted to use that iron plate to construct your home. How do you check the robustness of that iron plate? Yes, you will try to break it from the hammer, right? You will put hammer on it and then you put water on it. You will try to expose it to the sun. You will try all the necessary steps to check the robustness. So you will try to break that iron plate. In the same way, in this machine learning model, I am assuming, let's assume if I double the error, then in that case also is my model having a a big change in the error, overall error, or is my model have not much change in the error if I double the error, if I double the error. So in that case we can use root mean square residual. Yes, this will help you to check the robustness of your model. It's also known as root mean square deviation or residual. So the formula for root mean square residual or deviation is also known as RMSE, is take a square root of the root mean square. So I equal to 1 to n, and then we will put here our difference cap square. So now you're doubling the error, and then you're taking a root mean square, yeah, root square of that. So to check, basically if I double the error, what's the impact on my overall accuracy? To check the robustness of the model, can this model be trustworthy? So let's say root square of 0.5 square plus second value was 0 square plus next value was 1 square plus 0.5 square, divide by 4. What is it comes? This comes 0.25 plus 0 plus 1 plus 0.25, divide by 4. When you calculate, this value comes somewhere about 0.6123. You can calculate, use calculator in your PC, you can calculate. This is what it will come. Yes. Now, what the conclusion you can derive from this? If the value of RMSC is close to the value of root mean, yes, RME, MAE or RME, mean absolute error is close to RMSC, the model is good quality. The quality of the model is good, means it has ability to reproduce the correct predictions or close to near good predictions every time. Yeah, that is what tells us the quality of the model. Can I trust that model again and again for applying my machine learning? That is the characteristic, the second characteristic we calculate. The last characteristics which we calculate is called MAPE. So what is MAPE? This is what SAP Analytics Cloud will also calculate. It's called as mean absolute percentage error. Guys, notice it's an error. What is good for us? Error higher the good or error lower the good? Of course, lower the value of error is better for us. Okay, lower the value of error is better for us. So what is the mapping and what does it mean? So the value of RMSE can range while calculating between 0 to infinite. So the value of above parameter can go up to infinite, which is hard for business to predict or to confirm the robustness and accuracy of our regression machine learning model. So business cannot tell whether this model is good or bad just by looking at RMSE. So in this case, in order to make business understand the model better, we use another marker called MAPE or mean absolute percentage error. What's the formula of MAPE? This is what will be calculated also by SAP Analytics Cloud. That is how SAC calculates everything. So you don't have to do all these things manually. The system will do. That's why we are using computers. to do calculate all the accuracy and everything and tell us the final result. So that's why machine is being used to do these calculations. It's because these calculations are complex. But I just took an example to explain you how does machine do it. So 100 divided by n, I equals to 1 to n. Then it does a yi minus y cap I divide by yi modulus of that, and this is what comes the value in percentage. Yeah. Let us calculate for our scenario this value. So we have a 0.5 divided by 1 plus 0 divided by 3 plus 1 divided by 2 plus 0.5 divided by 6. 6 was our last value of y, I, yes. So we come as 100 divided by 3 into 0.5 plus 0.5 plus 0, yes, plus 0 divided by point. So how much 0.5 divided by 6? 0.08. If you calculate this value, it comes about 36%. This is your mean absolute percentage error, or called MAPI. Have everyone understood the concept of MAPI? Yes or no? In case of regression scenario, SAP Analytics Cloud will calculate MAPI for us. Have everybody understand how we started? We started from residual. From residual, we calculated the mean absolute error. Then we calculated RMSE. The value of RMSE can vary from 0 to infinity. So we calculate MAPE, MAPI. Analytics Cloud will show you MAPI calculation. So now let's go and understand our business scenario. Like last time we did a scenario for classification, we also have the business scenario for regression. Remember the rule: if the output variable is of nature continuous, we will use the regression scenario. So now I'm coming back to our material, and let's open this regression scenario. I'll open. Yes. So let's understand the business need to understand our scenario. Stella Johnson is a data scientist working with Anubhav Trainings. She is data scientist who have been devoted to the analytics industry and the development and use of data technology for several years. Currently, she is a data scientist on a full-time job. She works on an iOS top 10 mobile game, doing combination mix of user behavior research, exploration, data engineering, and statistical modeling. She is a master of digital marketing campaign design and analysis, as well as she has implemented various statistical and machine learning models to help solving real world problems. Before joining Anubhav Trainings, she was a statistician at Princess Margaret Hospital, where she published two papers on academic magazines covering the breast cancer research and image processing. So that's our user story. That's our end user. Yeah. So what's the business story? What is the use of the machine learning in our current use case? What's our use case? So our use case is insurance is not a over the counter physical product or an instant service. It's a promise. I'm sure some of you have already heard or done insurances in your life, whether it's life insurance, whether it is health insurance or medical cover, or whether it is car insurance. I'm sure most of you who are owning a car have also a car insurance, because it's mandatory as per the government law to ply your car on the road to have an insurance first, right? So insurance is basically a promise. When you buy an insurance, you're buying a promise for what? Promise for any mishappening. Suppose I'm driving my car and I met a small accident, it caused a damage to my car, but maintaining my car is very expensive for that damage. So that's where we have a promise. So It's a promise by insurance company that any damages to your car we will be paying, right? So, and the insured people expect the company to fulfill the promise at the time when they need it the most. So, I met an accident and I need that promise to be fulfilled by repairing my car for free, which is during the trouble time such as an accident. The success of an insurance company in long run is often based upon motor insurance claim settlement ratio. When you go to buy insurance on market, you will compare, right? How you compare insurance plans? Which company has fastest claim settlement and how much percentage of claims they have settled last year, right? That is what you compare. So a company might be making profit in the first place, but its customers are not happy with the claim process. The profit graph is poised to plummet in the subsequent quarters. So maybe you buy an insurance first time by looking at some offers, but you will not continue your insurance with the same company if they refuse to settle your claim when you need it, right? So when the insured raises a vehicle insurance claim, they expect the insurance company to settle it at earliest. However, the claim team has their own challenges while settling the claim. They have to rely on predefined car insurance claim process and have to coordinate with partner garage and other third parties and are bound to certain rules and regulations. So as the insurance company understand the pain, they want to settle your claim if it is genuine and they want to settle it faster. But they have their own challenges while settling your claim. Yes. So the general insurance industry is changing after its digitization. Insurance providers are becoming more transparent and claim friendly. The claim process is continuously upgraded to make it trouble free. Yeah, to make it trouble free. Stella would use SSC predictive scenario to help insurance company meeting their goals. The goal of a claim settlement department are improve customer satisfaction by expediting claim process, reduce the chances of false claim, and exorbitant claim amounts must be scrutinized. So these are the goals of our claim department. Now, in this case, why we got today Stella Johnson into the process and why we need Analytics Cloud here in today's context. The objective of SAP Analytics Cloud is Smart Predict are following. First, understand the claim amount per customer which is expected to come. So let's say you're insurance company and every day there are some claims coming. So you need to also have ample cash in your business to settle these claims. If you don't have cash in your business kept aside for claim settlement, how do you expedite the process? You cannot. So you need to understand the claim amount per customer which is expected to come. Observe the claim amount pattern with respect to customers' income per vehicle segment and check the tentative claim as per the policy type. So the overall goal here is to predict the claim amount which a customer can raise. Can anyone tell me what is the nature of claim amount? Is it binomial or is it continuous? What's the nature of claim amount? What's the nature of claim amount? Binomial or continuous? What is the nature of data? Continuous. Very good answer. It's a number. Continuous means simple layman way number. When it's number, which scenario will you use? When it's number, which scenario will you use? Classification or regression? Which one you will use? Regression. If the if the output was a nature of binomial, which scenario will you use? If the output is binomial nature, which scenario will you use? Binomial. Then you use classification. Very good, guys. That is it. If you understood machine learning in SSC. Okay, so below is the screenshot of claim data provided by claim department. You can see there is again our training data and we have applied data set. So let me open up the data set for you. So we have training data and apply data because we will do supervised machine learning. Yes. So I'll open this training data. In training data, what will happen? कौन बताएगा? Who will tell me? In case of training data, what will happen? In case of training data, what will happen? Yes, output is known. Output is known. We already know the output. What's the output? Claim amount. You see, its nature continuous. Yes. So we already know from the last year what was the claim caused by each customer for their policies. We know that based on last year experience. This last year experience we will turn into a machine learning model and we will predict for this year what will be the tentative claim amount. Yes. Is that clear? Hello? Is that clear for everyone? Hello? Yes or no? Are you clear? What is your training data set? The output is known. This is YI. Remember our example? Simple example with 3 data points, 4 data points. YI. Actual value. This is the actual value of claim amount. So what machine does, it will split this entire data behind the scene into two parts, actual and training data set and validation data set. It will do the training, it will prepare a model, it will compare, it will calculate MAPI, and then it will use different techniques to calculate MAPI. It compares the MAPI, it gives you the best model out of the box. And these all calculation happens behind the scene in the under the hood inside analytics cloud for us, and we will get a machine learning model with a MAPI. You can change parameters to again retrain your model to achieve the desired MAPI results. Okay, very good. So then we have the another data set, which is the apply data set. In this, the claim amount is not known. However, I wanted to show you one thing. In this also there is a claim amount, but this is basically the last year claim amount. Why? Because we want to compare what machine is predicting versus what was the total claim last year. That is the reason this is last year claim amount. So don't worry. In this, the current year claim amount is not there, which we anyway have to predict. But this is last year's claim amount because policy is recurring. Okay, let's upload this to as what? Anyone to do machine learning? What do we do? How do we upload these data in SSE? What is that called in SSE when we upload this data? Anyone? How do you upload this data as in SSE? Anyone? Do you remember or forgotten everything? Very good answer. Data sets. Why? Exactly. Machine learning scenario in SSE do not understand models. They understand only data sets. So come to data sets and upload. Now what I will do is right now I go back and remove some of the old data because we are using trial account. And since we're using trial account, we have a problem if we upload too much of data. So I'm deleting some of the data, guys. Let me go back. First, I'll delete some stories because I have a limit of the, yeah, I have a limit. So I'm deleting some stories. Done. I'll go back and delete now some models. Just want to clean up a bit because we're using trial account. And if we don't delete, if you have too much of data, SAP will refuse to upload more data because the trial account 200 megabyte is maximum you can use here. So I just need to clean up a bit. Yeah, this is the reason I'm just cleaning up my old scenarios. Okay, now let's go and create data set. So I will choose now my data set. So this is the data in my computer. Again, as usual, you're going to get this data set in our training material. So I will upload first the training data set. Put it in our dataset folder. You can open another tab to speed up your work. And in another tab, you can upload the another data set also. So both will happen parallelly. Train data set, apply data set. So apply one is I'm uploading, on which later on we will apply. So I've just uploaded both my data sets to start my machine learning scenario for our regression use case. Make sense? Now let us go ahead and see the data. So this is our data set. It's okay. It's just having customer state, customer rating, salary, basic idea, education, employed or not employed, income, marital status, yes, policy details, type of policy,
एकदम से
corporate or normal, how it was sold, agent or through call
क्या
center,
एकदम से लगता है
vehicle
यार
type
ये
which they own, type, size of the vehicle, everything is there. Just save. It's basically car insurance and their last year claim. And then also I have the final apply dataset. So which dataset will you be using to do training of machine learning model? Train dataset or apply dataset? Which dataset you will be using to training? Yes, train dataset. Let's go back to now over here and we will be choosing our dataset as a training dataset. So I'm just going to come to predictive scenario and you can see we have already done classification. Now hover the mouse on regression, it says you want to predict numerical value, basically the value of nature continuous based on
अभी आके
fluctuations in
लगी
correlated variable, basically the independent
अभी आके
variable
लगी
when they change. Remember the
चाय
coefficients
बना रही
algorithm, alpha 0, alpha 1 and stuff like that. Yes. Then predict the price of imported products based on projected transport charges and tax duties. That's an example they've given. Basically the output is of nature continuous. I click regression and now I will put here, go to SSC training, predictive scenario, and we will create a new folder. So see, I'm organizing my work always. Whenever I'm doing something in Analytics Cloud, I'm creating folders and subfolders. And then inside these folders, we are creating everything. So this is Stella Johnson, car insurance, prediction, claim. So claim prediction scenario for car insurance by Stella Johnson. Click OK. It starts the very same screen. So process wise same, only the input output is different. So first we choose our data set. I will go to folder, datasets, and we will use regression train dataset. Just selected the dataset. You see it has come. I say claim, predict the claim amount for the regression. Then I have a target. So my target here output is total claim amount. That is what we are planning to predict. Exclude influencer. So what will not affect, what will not exclude, not affect the claim, what will not affect the claim amount. So it's basically the customer name will not affect. If your name is Jack or your name is Peter, it doesn't matter how much claim you cause to the company, right? What matters is life value, income, premium, how much premium you're paying. Yes, important factor. Open complaint. Yes, number of policies they have, total claim amount. State, which state are you living in, because laws will change based on each state. Response, coverage, education, effective to date. Yeah, maybe because claim dates are coming very closer, uh, the the policy end date is coming closer. Employment status, gender, location code, marital status, Gender may not matter. Yeah, whether somebody's male female, it doesn't matter whether they claim. May matter because females might drive carefully, but males will drunken drive, so they may cause more accident and claim. Yeah, so let's keep gender. Then marital status may not. Yes. Renewal offer type, offer doesn't matter. Sales channel, vehicle class, vehicle size. Policy number doesn't matter. So some properties I have selected which I want to exclude. Yeah, exclude. Okay, so click on select, and then we can say limit the number of influencers by 10. Yeah, automatically. And now we can run and train our models. Remember, it's a supervised learning. Begin the training, you can expand the panel here, and that will start your training process. Yeah. So now let's take a break here for 5 minutes. And on the other side of the break, we will resume the session and we will analyze the results produced by the system once the training is complete. So I will be back in 5 minutes. Okay, welcome back after the break. So now you can see our model has calculated couple of parameters. So the first parameter is RMSE, root mean square error, as I already explained you in the slides. This indicates the robustness of our model to reproduce the same prediction result with quality. So this gives me the prediction confidence of 99.4%, which is very good. I can rely on the model. Then we have training and validation process. During the training, the minimum error was zero point 0.1 and maximum was this much. The mean value of each residual was 432 and the standard deviation was 287. Now, what is this minimum and maximum? So I already explained you that there are some data points which are above the prediction line and some are below the prediction line. So what you can do is, if you just go back and let's assume that you have a predicted model y equal to c plus mx, somewhere like this, something like this. Yeah. Now there are many residuals which are above, many data points which are above the line, and there are many which are below the line. So these black dots are, or these dots are your actual values, and the line is your predicted model, predictive model. So you calculated residuals and a mean of entire residual, but also you can calculate a mean absolute error for the residuals which are above the line and mean absolute error separately for below the lines. So this will tell you the maximum deviation it can go above the line. So this line you see, and also the one which is below the line. So you can calculate a mean absolute error of all the data point together and all the data point which are above the line and all the data point which is below the line. That is also a good indicator of how many data points are below the line which are deviating and how many which are deviating above the line. So this is what also this minimum and maximum is telling you. Yes. And then if you come back to contribution, location code is the highest contributor for claim. So which is true also. People living in the mountain areas, they tend to cause more complaints and more claims as compared to people living in plains. Then monthly premium is the second factor. More premium people pay, more the claim they will incur, which is true also in real life. Then okay, employment status is factoring another cause. So people who are not employed are tend to raise more claims because some people are just doing this as a business, take the claim and run their livings, right? So that is also another factor. Coming down, you can see this is your y equal to c plus mx line, the average of maximum residuals and average of minimum residuals is also what is projected on this particular line. So That is what we also saw in the example. Then contributors, again just the influencer contributors, it is telling you same data like last time, where it tells you what contributes maximum to calculate this premium auto premium claim amount. So now if I come back, we are ready with our machine learning model. Yes, and we can proceed towards creating a prediction. So we will now apply. So I click factory icon. I will now choose our data source for apply, and let me choose apply dataset. Predicted replicated column, I want to replicate everything. So please select everything. You can also do control A. Sorry, you can do control A, I think. Yes. So select one of them and then do control A. Yeah, control A. It will select everything. Okay. Now I say select, and now we will say what is the output we want. Outlier indicator, predicted value, prediction, explanation, and assign bin. Output as a new data set. This will be the result of machine learning execution on our applied data set. Just go inside to our data sets, and here we are going to create a new output. So once again, we can just go to predictive scenario, regression, and we can say output claim amount, insurance. Click OK, and now say apply. So it is now applying. You can see this hourglass icon. It's applying your model on your data set, and it is calculating the tentative predicted claim amount. Yes, it's done, which means the data set is produced. So next step is to create a model. So we go and create a new model, and this time I'll choose dataset to create my model. Remember, it's a good practice to create stories on the model, not on datasets directly. And I just go back to SSC training, my predictive scenario, my regression, output claim. Done. So we've got all the things, and if you can see, there will be a column called predicted value. You see here. So it has predicted that this customer will raise $563 of claim. This one 911, and so on. All the blank values I will replace with 0. Zero claim amount. Perfect. We are good now, and it has created everything which we need. Yes, along with explanation. Now I can click on create model so that we can eventually go and build the story for our claim department in the company. Click on create. Store this model in models, BI model, and I can say claim or claim amount insurance. Perfect. It's time to build a dashboard. So if you come down to the specification document, the dashboard is already provided what we need to build. So this is how the dashboard should look like. So first we have our company logo. Then we have the table showing the total claim amount, which was last year versus the predicted claim amount of the current year. And then there is a subtract column with a in cell chart. Let's go ahead and do that. So I'm just going to go back to create a new story, create a canvas story with classic design, and then we are going to go to create a table first with our existing model, and I will choose the model from our BI model, the claim amount model. We will first choose our rows. So we will choose here the customer name, and the important factors which we identified was the employment status and the location. Where is this customer from? Perfect. Is it urban or suburban? Then we can just go back and put here our filter on claim amount, which was last year actual value, or yes, and the predicted value together. So you can see this is the claim amount actual and this is the predicted value. We can calculate a difference by selecting these two columns, right click and choose a calculation of subtract repeating. Now we will right click on the subtract value and turn it to a in cell chart, and you can see the difference between the claim amount last year and this. How much is the difference? Perfect. So this is how we can calculate our table and put it for the HR team or the claim department team. You can also say optimize my presentation to display the data. Yes, a lot of these settings, styling settings, auto size the page table vertically, and we can just go to change it to report styling. So there are a lot of these settings which you can change for the table control. I'm just going to come back and put the table over here, and now I also get the company logo. So let's insert an image, add our company logo from our study material images, and this is a small image. So there's a question coming, what's the difference between subtract single and subtract repeating? So let me explain you what's the difference between subtract single and subtract repeating. Suppose you have data in your analytics cloud for, let's say, the sales and target sales. Now you have data for quarter 1 and quarter 2. Under the quarter 1 you have January, February and March, April, May and June. So the value of quarter 1 is total is 100. For the January it is 30, for February is 30, for March is 40. This is 120, it's 20. Sorry, one total is 120. Then we have 20, we have 30, and then we have 70. And the target value was 110 with 30, 35 and 45. And for this target value was 150, 50, 30 and 70. So now when I create a subtraction, how I want to do? I wanted to subtract only the quarter 1 and quarter 2. This is called single subtraction. But if I want my subtraction to be propagated for every month, I will go with repeating. Yes. Please repeat for every member in the hierarchy. Are you clear? If you just want to subtract at the quarter level, you go with single subtraction. But when you say repeat, it will start a loop on even the child elements and will calculate the amount at the child also. Yeah. Usually most cases we go with repeating subtract. Is this clear? repeating versus single subtraction? Your question? Okay. Now we come back and we have got the table over here. And the next thing which we want is we want a chart. So we want to show total claim amount prediction versus income of the person per vehicle class. So let's add the chart. Income versus predicted claim amount. So add measure income versus predicted claim amount per vehicle class. So my dimension is going to be vehicle class. And I want it to be vertical. And we will go with a combination of line and column. And my line is going to be income. So how the people's income is versus how much they are claiming. So you see in the two door class car segment, people's income is more than what they are claiming. Yes. In this segment, four-door, it's same. But in other segments, as compared to their income, the claim which was drawn was higher. This will help you to scrutinize the exorbitant claim amount, which was also an important goal of the process. You can use different color palettes to choose. Yes, nice. Okay, moving on. Let's go and add the third one, regression claim model, where we want to put total claim per policy type versus assigned being. So let's come back and add per policy type what is the total claim amount. So add our dimension policy type versus total claim amount. So total claim amount and predicted value we will compare at vehicle class level, policy type level, sorry. And what I will also do is I will immediately go ahead and create examine, and we will create a comparison chart with the reference line on average. Or it's okay, let's copy. Stop the examine, close the examine panel, and we got here this value, which we can keep it on the side. Okay, next I would like to go to this chart and add some smart insights. We learned this feature in the past. Next, I want to also put a comparison between total claim amount versus actual last year claim amount. So let's do that. So let's add a donut chart. You can be creative. You don't need to follow exact specification. You can be little creative and just see what is best suited according to your requirement. So predicted versus claim value in a pie chart per category, per policy. I think it's since we're doing comparison, we have to use the comparison chart only, predicted versus claim. And I can remove this chart. So the total predicted versus claim amount. So last year versus this year prediction comparison we are quickly getting over here. Okay. Now we will add a filter on state so that user can filter these everything based on state. So let's go and choose a filter control based on state. And we got a state filter also. Cool. Nice. So that is our dashboard. Let's give a beautiful look to this dashboard by going and changing a background. So I'm going to go plus add an image background. and we will go with this purple blue mix. I'm uploading, and I've already uploaded everything for you into the study material. You can download from there these images, and we are just going to zoom out a bit, increase the size of this image bit bigger, and put this image over the top of our content, and then make this image go to the background. So make this image go background. We go to the preferences, and then we just go ahead and put here the color. We'll put a white color, looks better, because on a darker white looks better. Fantastic. Look at that, how beautiful your dashboard look like. So this is how you can help your company's claim department to predict the tentative claim amount value which may arise due to the next year claim with the help of machine learning model. So the predicted value or the output is of nature continuous. We use the regression scenario. All right. Now moving on to the next scenario, which is called segmented time series or time series. So what is segmented time series? That's our next machine learning scenario. When do we use segmented time series? So whenever we want to predict output which is of nature continuous, again just like regression, but also with a trend, which means it's a always function of time. Yes, whenever we want to predict an output which is of nature continuous, means it's a number, but it's a trend. Yes, along with a trend, which means it's a function of time. Function of time. What we do, we will go with segmented time series. Segmented time series is what we will go with. Clear, everyone? We'll go with segmented time series. It's a function of time. We go with segmented time series. Perfect. So there is another reason why we go with segmented time series. So time series, I understand it's a function of time, but what is segmented? The segmented means the model also have ability to calculate trend and values for each segment, basically category. I'll take an example. Do you think the shampoo is sold in a store at a same rate, at a same pace as cars in a showroom? Do you think shampoos in a store is sold at a same pace, same speed as the cars? Of course not. So in this case, shampoo and car is a product segment. Yes. So if I want to predict value or the cost of a product based on inflation rate and different factor, based on function of time, whether the cost will go up or down, but for each product segment, shampoo, for let's say hair oil, or let's say beauty products, yes, or shoes or cars. So in that case, the trend is different for each product. Each category, the trend will be different. It will not be same. So we would want to do this for each category, each product segment, to predict the price of a product based on different factors, and that too whether the price is inclining or declining. Trend means we want to calculate whether it is inclining or declining. Trend means incline and decline. It's always a function of time. So in that case, we use segmented time series. So you don't have to loop yourself. The system will do the looping for you. So what SAP Analytics Cloud does behind the scenes, when you start your predictive scenario using Analytics Cloud, it will first predict or detect the trend. Then it will do something called cycles, and it will repeat the cycle for each segment. Basically do the loop. Okay. It does a loop. Yes. It predicts the loop, and then it calculates the fluctuations or the errors, and then that's when it will create a predictive model. So model comes out. So this is how the calculation will be done. So you see, basically it will do a loop on each category to detect its trend and its errors separately. Imagine if you want to predict price of a share market stock. Now I take two companies in stock market, Apple, and let's take another company, MicroStrategy. What Apple does, they manufacture iPhones, they manufacture hardware products. Yes. MicroStrategy is an investment firm. They invest in cryptocurrencies. So Apple versus MicroStrategy, two different companies. Two different companies. Apple, MicroStrategy. If I want to predict the stock price of Apple, can I use the same rule for MicroStrategy also? Are they belonging to same segment? No. Apple is a hardware company. Yes. They operate in a different segment. But MicroStrategy is a different segment company. If I want to compare MicroStrategy, they are like PwC, KPMG, yes, investment firms, BlackRock. Yes, these are the investment firms. So we should segmentize it differently, and Apple should be segmented with technology companies like Google, Microsoft, yes, Amazon, something like that. So in this case, if I want to predict the price of their shares, it is a function of time. You see, share prices will change time to time. So we want a inclining or declining trend. Yes. So that is what we want. It's a function of time. Both of them are function of time. But since they both belong to different segment, today if I need to do this prediction with regression, I need to create two different models, two separate models. But think about it. If I create two separate model, how many segments we have in stock market? We have many segments: oil and gas, FMCG, pharmaceutical, manufacturing, investment. Yes, I need to create so many machine learning model in Analytics Cloud. SAP says no need to do that. If you think you want to do a trend analysis, you can use segmented time series, and Analytics Cloud handle the complexity behind the scenes. For each segment, it is going to calculate the trend and cycles and fluctuations separately for you. That's the beauty of Analytics Cloud, and that's why it's called segmented time series. If you not understood this discussion, it's okay. Once we see our practical scenario, you will understand it better. So let me explain our scenario. What is our scenario? What we want to achieve? That's our next scenario, time series. So meet Roger Morrison. Roger Morrison is a data scientist working with Anubhav Training. He is a data scientist specialized in working in education industry and social status of underprivileged children's. He works with the federal government with various projects like Education Right for Everyone, Learn to Become Expert, and more. He helped governments of USA and Canada scrutinizing the financials of educational institutions and help government to plan their education expenditure and budget. So governments will spend a lot on education, but it doesn't make sense to spend a lot on an institution which is over expending. Yes, right. So some institutes which need more help from government, there that should be ideal candidate for government to spend. That can only help once we know how much is the revenue and expenditure of each educational institutions and how did it change over a period of time. So with over 32 years of domain experience, he is holding a precious award as one of the government's best advisor for risk and budget planning on education sector. Let's talk about the requirement in the business story. The United States Census Bureau conducts annual survey to assess financials of elementary and high schools and dataset containing a summary of revenue and expenditure for years 1992 to 2016, organized by states. Roger will review and analyze revenue and expenditure of past years and explore both expenditure and revenue across all 50 states using a smart discovery feature and forecast for next few periods. So basically we have data of revenue and expenditure of all 50 states of America for different education institutions since 2000 since 1992 to up to 2016. So that's the data we have. Again, I repeat, we have data for from 1992 to 2016 for revenue and expenditure of education department of each state. So there are 50 states, so 50 into number of years of data. During exploration, we will find that revenue and expenditure patterns are different for each state. So one model, one analytic cloud predictive model cannot work for all states because each state have different policies regarding education, right? So Arizona versus Florida versus Kings County, they all have different policies for their education department. So if you want to predict the revenue and expenditure for coming years after 2016, one rule may not work for all states. To improve the forecast accuracy, it is necessary to model each state separately and require 50 models as we have 50 states. Think about it. If you do this scenario with the regression to calculate the value, point 1 you cannot calculate the trend. Point 2 you need to create 50 regression models because there are 50 states and each state operate differently in terms of their policies. So normally modeling 50 states separately is a tedious work. But Analytics Cloud segmentation will help us to accomplish this easily and then consume forecast result in our analytics. So in this case, you can see we don't want to create 50 model. So we will just use segmented time series and our category will be the state. So let's look at the data set. In this case, we want to do just the forecasting. So this is a unsupervised learning. We will not have training and applied data set. We'll just have one data set where you see the state value, the year 1992 up to 2016, we have data for each state. There are 50 states. So for 1992, 50 records. For total revenue and total expenditure by each state. Yes. So this is the data we have in our data set. So the idea is here is to predict after 2016 what will be the value of expenditure and revenue. So we have data till 2016. But for 17, 18, 19, 20, 21, 22, I don't know what will be the value of expenditure and revenue for these states. So we want to predict the value which is of type nature continuous, but a function of time. And for each state, the rule of the model will be different. Hence, it's a perfect example of time series, segmented time series scenario. So let us go back and first, as usual, we create our data set. So I'm going to switch over back. I will come back to Analytics Cloud and create dataset. Dataset is the raw data, is the fuel for building machine learning scenarios. Import. I will go to our SSE training datasets and import. It's getting imported. Okay, there is nothing to change here in this case, and I will simply go ahead now and create our machine learning model, predictive scenario, and the last one, which is the segmented time series. So come here to predictive scenario, the time series. If you want to predict a numerical value over a period of time, taking into account variable that may or may not be correlated, like your segment, like forecast the volume of ice cream sold by retailer for future period using historical sales info along with the month and temperature data as a variant. So I can go inside and create a new scenario, store it in our predictive scenario, create a new folder for time series, and I can say federal government revenue and expenditure model. So we'll create two model, one for revenue and one for expenditure. So two predictive model in same scenario. So scenario can have multiple model. We'll see that today. So now I'll choose here forecast, revenue and expense. I choose our data set, US expenditure, education expenditure. I will first choose calculate total revenue. The date dimension is year as date. I want to calculate for 4 years after 2016. And now my segment is my state. Remember, I don't want to model 50 models because there are 50 states. I will use state as my segment, as my entity. So system will loop behind the scene on this state and calculate the MAPI, mean absolute percentage error, for each state separately for me. Train using all observation until last observation, exclude column influencer, total revenue, year as date and state. So in the exclude, I think we have to choose year as date and state, I think. So let me just choose here total revenue. No, I think we can leave it empty, no problem. Hopefully it should work. Let's give it a try. So train and forecast. So now I'm creating for our first model for total revenue. You can see it's running. In the meanwhile, I'll create my second model. Okay, there is an error, guys. I think I've done a mistake. So we need to correct. So you see, it is telling you many things. So we need to go back and we need to correct this error. So in the exclude as influencers, I think we have to change here this value and we need to put here all the other values except the total revenue. So we will put here, I need to check what is the value we need to enter. I have forgotten. Just give me 1 second. I will check in my notebook what is the correct value we can add in here. So it's been such a long time I did this scenario. So I've forgotten what's the correct value we need to enter. Just give me 1 second. I'll check it right away. Okay. So we need to exclude everything. So control A. except what we selected in the other values. So total revenue you exclude, year as date exclude, and exclude the state. So apart from that, select everything. Yes, that is what you have to do. Train and forecast. And now you will see the model is getting prepared. This is a model for revenue. Now I'll create another model as a copy for expenditure. So two models I duplicate, and the second model is for expenditure. In the second model for expenditure, we will choose the target as total expenditure, and we will exclude total expenditure from here. And then we are good. So we will begin with the training. Why the train button is not enabled? I don't know. Let me just check. This is a bug in SSE that the train button is not enabled. Maybe I have to choose the data set again to make the train button enabled. That's okay, we can do that. So we say total expenditure, date, state, all observation, and I will select everything. It's not enabling this button. So let's go to model 2. Yes, now the button is enabled because something was already running. It didn't enable the button, but now it is enabled for expenditure. I click and you see it is training my second model. It's an asynchronous process, so you can move out of the screen. It will keep running in the background. So you see model 1 is ready. If I go to model 1, I will now see here the top and bottom entities. You see it is calculated MAPI, mean absolute percentage error. So what is MAPI? Is MAPI higher the better or MAPI lower the better? Anybody? Remember I explained MAPI today. Is MAPI higher the better or MAPI lower the better? Yes, MAPI lower the, it's an error, mean absolute percentage error. Lower it's the better. So you see top entities, Delaware, state. Yeah, this state is a top entity because lowest is the MAPI. North Carolina highest MAPI, it's a bottom entity. Means the predicted values are not so accurate, but in this they are better accuracy. Average MAPI is 3.07% at model level. You can see expected MAPI. Yes, we can see forecast values per state. However, for this forecast value per state, we will be creating a separate dashboard. You remember the algorithm of regression, but this time it is the predicted value along with the with time function of time, guys. And you see here, this is max residual, this is min residual. Average of min residuals and max residual, it's a function of time. It's predicting more value after 2016, 17, 18, 19, and 20. It is predicting the value. You see, these are predicted values. Yeah. And MAPI is this for this state. So you can change the state and you can see the MAPI for each state separately. Mean absolute percentage error. So we do not need to create 50 models. One model is enough to calculate revenue, and one model is enough to calculate the expenditure. So both the models are ready. And now we can just output the data of our forecast to another data sets. So let's go to model 1. I will click factory icon and save my data in dataset, sorry, in prediction scenario, time series, and I say output, and I will say here output dataset for revenue forecast. save, and I'll select second model. For expenditure, you see again it has got the MAPI, everything, same thing. Let's click on factory icon and also output this. Expenditure. So now I have created a output expenditure and output forecast for revenue. Two separate models gets created. When the models are created, after that we will create our, so the data sets are output data sets will be created as output data sets, and we will create use these data sets to create our model on top of them. So let's create model on top of these data sets, because usually to build a story we first create models. So let it run. I'll go to another tab. I'll create model. Create model from my data set. I will choose here data set, and we will go to predictive scenario, time series, output revenue forecast. I'm creating model. I'll show you now the benefit of creating model from data set. So you see we've got the forecast value, error minimum, error maximum, states, and year as date. But we don't have information about the geo coordinates. And if you want to plot this data in a map, you need coordinates. No problem. You can click this map button and click on area name. And now you can choose country, which are predefined by SAP Analytics Cloud. So I'll choose United States, and I'll choose region as state. I don't have sub-region data, county data. I just click on create. System will automatically add the coordinates data. Wow, there you go. That's the beauty. That is the reason why we prefer to create model on top of dataset before creating stories. Click on create. I have the model now. So I go to models, be a model, output revenue forecast. Model is creating. So we had the first dataset for the revenue. Now I will create another model for the expenditure. So let's go back. Model, dataset. Steps are same, guys. The process wise everything is same. And we will take predictive scenarios, time series, and I take my expenditure forecast. Once again, I want to enrich this data with geo coordinates, area name, select predefined countries provided by Analytics Cloud, and the region, state. Done. Click on save. Everything looks good. Fantastic. Create model, save it in our model folder. So now I have got two models with the forecast value. It's the time that we go ahead and create a story. So when you come down to the specification, you can see the stories like this, where we are showing for each state how much is the total revenue and total expenditure for each state with yearly forecast. Yes, this is our output, final output, how we want to look at it, our dashboard. Then for each state also there is a filter and there is a forecast in a time series chart we want to show. Let's go ahead and do that. So we'll create a story, canvas page, and we will add two geo maps to show the expenditure and revenue spread across US. Yes. So now I will just go back and choose our first map. I go inside add layer and we will choose chloropath drill layer. We will now select our model, and of course I will select expenditure model and forecast revenue model. So one by one we'll select. First we'll select revenue. It's not showing here. Something is wrong. It's actually not showing my geo coordinates which I've added to the model. Something went wrong. It should ideally show that. Let's see. For other layers also it is not showing. I doubt if it has added the location or not. Have I selected the model correctly? Let me check. I should not select datasets. I should select model. Yes, you can see it has come. Yes. So we will choose here the region and the measure is going to be total revenue. You can go to the map and drill down to the area region and it will show for each state separately. There you go. Wow. Amazing, guys. That's the beauty. So for each state you see separately there is a breakdown of state in revenues. Lighter the color, higher the revenue. Let's select the second map. Choose the model. Go to output for predictive scenario time series and we will choose expenditure. We choose chloropath layer. Actually, there is a problem in our output of this one. Something is wrong. Something is wrong in the expenditure output. The map is not coming. Maybe I have to redo the process to check it. Anyways, then we will add just also the revenue by far from 2016 to 2020. For that, we will add a chart and I will choose my model first for expenditure, add measure as total revenue. Guys, something went wrong. You see it showing revenue here. Why? We have done something wrong. Let me go back and check again for model 2. So this was revenue for model 1. For model 2, I think it has done a mistake. It has not calculated for expenditure. I'm so sorry. I need to do it again. So it should be total expenditure for model 2. Train and forecast. So now you see we chosen expenditure correctly. So something went wrong in our model and the data set. Never mind. We can do this really quick. I can delete the created model for expenditure. So we can go back and quickly delete the extra model which we created, the wrong one which we created for expenditure. Also delete this output. It's incorrect. and I will run the model 2, which is for expenditure, once again to produce the output data set. So we just clean up a bit of the wrong things which was generated. So output revenue forecast, this is correct. We need to add output expenditure forecast also. So I go back and now this is expenditure. Yes, correct only. Let's generate as output predictive scenario time series expenditure forecast. Done. So once again, I'm calculating. So first we create the model, machine learning model, then we create data sets, output data sets. We create for each data set a analytics cloud BI model, and from BI model, we'll create the story. That's the process we are following. I will just make sure that I will also delete the bad guy, the bad model. This is the one. I don't know if it will allow me to delete. Yes, it did. Okay. So now we can create the model. So you see it is done. Let's create a model once again from dataset for the wrong thing. Predictive scenario, time series, and now we have the expenditure forecast for which we can create the model really quick. We will also add the location. Enrich it with the geo coordinates and then save our model in BI model folder. It's done. Let's come back to the story. And now we will select the second map and we will choose now our model. The expenditure one. And yes, now we got the region for expenditure and we can just drill down to the area. So on one side I have forecast and on other side I have expenditure. Perfect. Cool. The next page which I will add is the forecast. So that will be a time series forecast chart. So let's add a chart and you can see here we have got the time series function of time. So I want to plot here my measures as forecast, expenditure, maximum and minimum errors, everything. And I can change color. So what is the total expenditure? I will show in blue. What is the forecast? I'll show in orange, but errors I will show in red colors. Minimum and maximum errors in the red color. Yes. I will choose dimension as my year as date. So you can see it has come. We will change the date parameter to monthly. The drill down to monthly, yearly or quarterly. So you can see all the data over here. Yes. Okay. Now what we will do next is we will just go ahead and create one more for the revenue. So I copy the chart and put it next to it. And change my model to revenue model. Once again, we will choose here forecast value and total revenue model. and we will change the color. So revenue will be blue, forecast will be orange, and the error minimum and maximum will be red color. Perfect. We will choose here the dimension as our year to date, and that is how our time series would look like, which is predicting the value for each year. You see 2020, 2019, 2016. Yes, that is how our chart would look like for the revenue data. Also, let's also add a filter for each state separately. So for revenue, I will add a filter on dimension called state. Maximize it, put it next to the revenue, because we are using two model in this story, so be careful. And the first one, I will just go back and change, create another control and edit input control. Okay, I think we need to create a new one for revenue separately. So we change the model here and we will choose our expenditure model and say dimension as state. So now you can choose the state and you can see the trend for that state alone. Yeah. So you see this is the forecast. So I just uncheck and I say Alabama. You can see the trend for Alabama. California, you can see the trend for California. So for each state, you can analyze separately what is the value of expenditure and revenue for each state, and along with the forecast, which is a function of time. So predicting multiple values of continuous nature, which is a function of time for each segment separately. That is what segmented time series is all about. Yes. So I hope you understand the need and when to apply which scenario in what cases. So this is what our basics for building our segmented time series, which is the last type of predictive model. Before we close today's class, an important update. Tomorrow we don't have a session, but it doesn't mean the learning stops. In our training block, we have provided you complimentary videos. So I would request each one of you to please go to the training block, and in the training block, let me also log in quickly. Let me just enter my credentials, guys. Just give me 1 second. I'm entering my credentials. Yes. So when you come to our training block, if you come down at the bottom, we have provided you complimentary videos on JavaScript. I would beg you all to please, please, please go through these two complimentary videos on JavaScript and this complimentary video on OData basics. Because without these three videos, you will not be able to learn our next class, which is Analytic Designer. In order to become expert on Analytics Cloud, these three things are mandatory and I provide these as complimentary to you. They are from my UI5 training actually, but I think it's important. So I providing these complimentary videos to you in our training blog to learn basics of JavaScript and basics of OData. So please go through these three videos. They are extremely important for our next discussion and next big topic on SSE, which is Analytic Designer. We don't have a session tomorrow. We will meet next on next Saturday, which is for most of you Friday evening. Yeah. So our regular class will continue from next weekend. Please practice whatever we have learned today. You have tomorrow's off and the entire week ahead of you. to go through those complementary videos as well. Any questions before we close today's class? Yes, you need to practice. I agree with you. You need to watch the video, take the data set and practice. That's when you might have more questions. Fair enough. With that, it's a wrap on today's class. Catch you up in the next episode. Have a nice day and goodbye.